Okay, sugar cubes, let's do some more U substitution work, except this time we're going to do some advanced examples.
No, God,
So
please,
this
no.
is our first one. Again, U substitution, you're always going to look for something where one of the functions is the derivative of another function. We can notice that x cubed plus 2x plus 4, when we take the derivative of this, it's going to give us 3x squared plus 2. So that's going to give us a hint that our u is right here. And that makes sense, again, because a great trick for u substitution, if it's like ln of a function or sine of a function or e to a function or like a function to the power fifth, if there's like if there is a function inside of another function, a lot of the times your u is going to be the little function that's inside. So in this case, that's true, because if we take du, we're going to take the derivative of this, giving us 3x squared plus 2 dx, of course. So now we can start rewriting this with u and du. So, all right, we're going to have to take care of this e to this little number here. So if we put e to the u, that's going to take care of this. And then we need to take care of this 3x squared plus 2 dx, which is equal to du. So we just put du right there, easy as pie. So, okay, if we take the antiderivative of this, it's going to give us e to the u plus c. And now we know our last step is to just plug in u into our solved integral. So this is going to be our answer for this integral. So remember when I was talking about if you ever see like the sign of a function, try to have the u be whatever's inside. We are seeing that right here with this ln. So let's just see what would happen if we put our u as ln. Our du would be 1 over x dx, which makes sense because we need to take care of this 1 over x right here. So it works. That's not going to work every single time, but that's a great sort of fast hint. So now we can rewrite this. That's going to give us sine of u, which takes care of this sine of ln. And now we just need to take care of the 1 over x dx, which is written here as our du. So sine of u du. Okay, the antiderivative of this is negative cosine u plus c. Now you know the drill. We just have to plug in our u, and there you have it. This is the answer. This example, there's no like function within a function, so we don't know exactly what our u is going to be, but we need to look for a function where the derivative of the function is also in this big integral. So we notice that there's an x, like a 1 over x, and there's also an ln x. We know that ln x, if you take the derivative of it, it gives you 1 over x. So let's try u to be ln x. That would give us du to be 1 over x. So we also have this 3, but this 3 is just multiplying the whole thing. So we could just move the 3 to the outside. This becomes a 1, and we just take care of it like that. So if we're writing our integral, we put the 3 on the outside. Now let's take care of u. Let's take care of you, babe. You care about passing this class, and I can get you there. I will tutor you. I will make you videos like this. Hit us up in the links in the bio. I got your back. Aww. It's going to be 1 over u. And then now we have to take care, so that we took care of the 3, we took care of the 1 over u, which is ln x. Now we just need to take care of this 1 over x dx, which is right here as our du. So this turns into ln of u plus c. 3 ln of our u when we plug in is ln, so 3 ln x plus c, and this is our answer. This one looks kind of scary. So let's see. First, we have these hints that cosine here is like it's a cosine of a function and sine of a function, and these two are the same. So what if we picked our u to be 5x? Well, that would give us du is equal to 5 dx. But then if we tried to write this out, it would just be cosine of u over e sine of u, which doesn't really help us out that much. So this is an example where the function inside of another function won't really work, except it kind of does, because this e is also to a function, which falls in the same category. So sine of 5x is also related, like if you take the derivative of that, it's going to be related to this cosine of 5x. So let's try our u to be sine of 5x. That would make our du, with the chain rule, it's going to be cosine of 5x and then times 5, because we have to take the derivative of the inside function. So that's going to simplify to 5 cosine of 5x dx, of course. So now let's start to rewrite this. So let's try to rewrite this now. We don't have a 5 that's being multiplied in here. So we do have a cosine of 5x on its own, but doesn't have this 5. So we're going to have to divide everything by 1/5. Now we can start to work with this. When we rewrite this, it's going to be 1 over e to the u, right? And that's going to take care of this. Now all we need to take care of is this cosine of 5x, which we have right here as 1/5 du. So this is going to be times 1/5 du. But let's move this 1/5 to the outside to simplify it a little bit. So it's going to be 1/5, 1 over e to the u du. Okay, so now you might be like, all right, well, is this just ln of e to the u? This is a super common mistake, and it's not true. If it was 1 over u, the integral of 1 over u would be ln of u. But it's 1 over a function, which doesn't equate to like the ln thing. So we have to simplify this a little bit to make it easier for us to integrate. So this is going to be the same as e to the negative u du. All right, now let's work with this. So this is where things get a little tricky.
Bruh.
We have a function to like something that's not just u. If it was just u, it would just be e to the u and we would call it a day. But we have this negative here, so we have to do another u substitution. So let's say w is equal to negative u, dw is equal to -1 du. So now we have to rewrite this as something that we can kind of work with. So if w is negative u, then we could write it as e to the w, which we could work with. And then we just need to write du. We have -1 du right here. So let's just switch this negative to the other side, giving us this. So now we can rewrite this as negative e to the w dw. This negative is coming from this negative dw here. Okay, now this is going to give us -1/5 e to the w plus c. Okay, now we make this u substitution here, -1/5 e to the negative u plus c. And now we just have to plug in u here. So -1/5 e to the negative sine of 5x plus c. And this will be your answer for this derivative, for this integral. Pretty tricky. That one was really tricky, but kind of fun, right? Okay, this one is u substitution with trig. Trig is really tricky because you just have to have a bunch of things memorized. So I'll do a whole other video on trig substitution. But what you're going to need to know for this one is that the derivative of tan is secant squared. Oops, secant squared. Okay. So let's work with this. Look, function inside of another function. So let's try our u to be 5x plus 1. Our du would be 5 dx, which works because we have this little situation going on here. So, okay, taking the integral secant squared of u du. Now that looks like it'd be really hard to integrate, but it's not, because we have to memorize that the derivative of tan is secant squared, which is like, I don't know, trig is so annoying because you just have to have things memorized. Like there's no way to know it unless you have it memorized. So I'll do a whole video on that. But that would give us tan of u plus c. And then when we plug in our u, it's going to give us tan of 5x plus 1 plus c. So those were some really tricky u substitution examples. Hopefully your quizzes and tests aren't going to be as hard. If you are still confused, hit me up for tutoring. I tutor remotely, or I can make personalized videos just like this covering your homeworks in YouTube, or covering your homeworks and practice tests or whatever.